Alright, so here we go. It's time to tie it all in together and finalize our particle system. We've done all the hard work. We've created the particle, which is the biggest component. We created the emitter, which uses the particles, and now we got to create the driving class, the main, which is actually going to make instances of the emitter and make it happen. So, which is not a lot of data that we need here. There's more UI data and things like that that I need to pass around than anything. So I've created an instance of the emitter class called test, just because this is a test program. And I've created two texture 2Ds, one for the emitter, one for the particle. And just for user interface purposes, I've created a mouse state variable, so basically I'm going to trigger the emitters when I click on the screen. And there's that random number generator, one per program, that we're going to pass into the other classes so they can use it. Again, one per program. Inside initialize, I've set the mouse visibility to true, just to so we can see where I'm clicking on the screen. I've also added ball, which is basically the Halo bomb from Halo 3, I believe it is. It's just an image that I had kicking around. I found it on the internet a while ago, and I've cleanly added it to the project in the images/sprites folder. And this is actually loaded inside the load content, as you can see here. I've actually loaded the same image for both the emitter and the particle because I'm too lazy to find a second image. But that's the way it is. And below that, I have three different versions of the emitter. So they're all using the same variable, so I have two of them commented out for now, and you can play with these as you want. But basically all I've done is I've set up all of the information, and all I'm doing is calling the constructor for the emitter, and I'm doing all the parameters here that you see here and structured here in the exact same order and structure here, so you can go back and check one-to-one. Hey, what's this mean? What's this mean? What's this mean? Very easily. So the very first thing we see is the rectangle for the screen bounds. So it starts at the top left corner, and then I've grabbed the screen width and the screen height for the screen bounds. Here I'm actually passing in a null value for the emitter image, and this is just to show you that you don't actually need one. It's fine. But I do still need a location to start emitting from, so I've created a rectangle, which is the top left corner and has a 1x1 pixel. The next number represents the number of particles in the particle system. So in this case I have it set at 1,000. You could increase or decrease that as you feel necessary. Just be mindful, the more you add, the more chug it is on the CPU, and you may cause your game to slow down, especially if you're doing collision detection on each one of those particles. So be mindful of this. So I've just got it set at 1,000 for now. In some of the other particle simulations I've built for these classes, I've had it up to like 250,000 particles without much of a hiccup. So you can do quite a bit with it. So anyways, so we have 1,000 particles in the particle system. If you forget which each variable represents, again, that's why I've lined them up appropriately here, so you can always go back and see which one's which. Anyways, so 16 represents your launch frequency. How much time has to pass before we're going to do more launching. 5 represents how many particles are going to be launched when that launch frequency occurs. True tells me that it's a cycling particle system. So when a particle dies, it gets recycled back into the emitter. Then we have the particle image, and we have the width and height of the particle image. Here I've just set it to 1/4 of its original size. And then 1F represents its transparency value, where I'm going to have it completely opaque. True, this is for collisions, so I have collisions, wall collisions, mind you, turned on for the particles. So when it hits one of the walls, it'll bounce off the wall and move in the opposite direction. If it hits the ground, it bounces off, and it reduces some of its speed, so it simulates a loss of kinetic energy. Then we get into the other values. We have gravity, which acts as a 130 pixels per second force. And wind I have completely turned off at this point, so it's at a value of 0. Here, this is a volcano, so I have it launching in a pretty wide cone between 45 and 135 degrees. So it's a pretty wide cone. Might even be too wide. We'll narrow it down a little bit. Then next we have our speed, so it's going to launch them between 100 and 200 pixels per second. We can increase that if we want. And then its time span, its lifespan. So its lifespan is between 2 and 3 seconds, and then there's that random number generator that's passed around. So this creates the emitter. It doesn't actually launch it or start it or any way, shape, or form. That happens in update. So down in update, Very basic. I've got the state of the mouse, which we have to do every update, and if the left button is clicked, I'm going to set the position of the emitter to my current mouse position, so it focuses on that location, so it's going to launch wherever I clicked, whatever the emitter is, and then it's going to start the test emitter. Awesome. Outside of that, I'm just going to comment out this line here. Every update, it's going to call the update code on the test emitter, passing in the amount of time passed since the last update. Game time, .elapsed game time, .milliseconds. Okay? And this line that I commented out here, if you uncomment this, it will have the emitter follow the mouse around after you've started it. So basically, it just keeps reassigning the position of the emitter to the current location of the mouse. It's up to you. It depends on what you're doing in your program. The draw is very simple. I start the batch, I begin the batch, I end the batch, and in between, I call draw. That's all there is to it. That's the whole main program. So let's play with it for a little bit, just so you can see what happens. So right now we have our cycling volcano, which does recycle, does bounce off walls, and launches between 45 and 135 degrees. So if we run our program, let me just move this over. Now wherever I click, it should start launching. There we go. We got our nice volcano. It's pretty smooth. I know it looks pretty choppy for you because you're running at 10 frames per second, and I'm looking at 60 frames per second. But I can tell you it does look quite smooth from this end. Now if I launch it here, it stops emitting from here. The ones continue with their lifespan while they're there. Let's launch it from here so we'll get a bit of a floor and a left wall bounce. Boom, 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 boom. We launch it from the top. Everything just kind of launches off and falls on. Looks like I got a bit of a bug up there, which it's kind of getting stuck on the ceiling. I don't know why that's happening. I'll deal with that later. Anyways, so we can continually do this. Let's start playing with some of the data. So for example, let's increase it to 10,000 particles. Let's see what happens. So we run our program, and we should get quite a few particles popping out here, and it's going to look quite a bit more full at this point. It's just a deluge of particles here. Let's reduce that, and let's play with some other numbers. Let's set our let's increase our let's play that. Let's turn off our wall collisions because we don't really need them. It's fine. But next, what we're going to do is we're going to decrease our cone size. So let's have it going between 60 and 120 degrees. So it should narrow the cone of launch. And let's speed it up a little bit. Let's say as fast as 400 pixels per second and as low as 200. So it speeds it up quite a bit. Its lifespan is still at 200 by 300. Let's run our program. We'll launch from here, and we should get a much higher cone now, and things start to fall down. And that looks probably quite a bit more like a volcano since they're launching so fast. And now let's get it to follow the mouse. So just by uncommenting this little line here, which happens every update, I'm going to run this. Now when I click, let me just move this over, you'll see it actually follows my mouse around the screen. So you can get some pretty cool effects with this depending on what you're doing. Now I have gravity going up at this certain speed. If I change this, let's change gravity. Let's give gravity going down in the opposite direction. It's going to pull, and so instead of launching up, it's going to launch everything down. Or not. What did I break there? Somewhere I reversed something. That's a... Oh no, that's right. Yeah. So it's launching everything up, but it's not allowing it, it's not pulling anything down. That's right. So it looks like almost like bubbles kind of floating up, or smoke or something like that. So again, you can simulate a lot of different cool effects depending on what you want to do with this. So let me just show you one more thing. So there's another version of this. I'm just going to leave those settings the way they are, so you'll get the demo with this changes. I'm going to comment out this section, and I'm going to uncomment out this version. So this is the explosion version, and this one should make everything go boom. So here again, I don't have an emitter turned on, but I've set the launch frequency to emitter.explode, and it's at 1,000 particles. Let's make it 10,000 particles just because we can. We're having a full range of 0 to 360 pixels, and they range between the speed between 10 and 400 pixels. The same lifespan of 2 to 3 seconds, and gravity still working at 130 pixels per second, and no wind. So let's run our program. And now wherever I click, we should get a nice explosion. Whoa, that is a lot of particles. And it almost came out like a perfect circle because there were so many particles. So let's reduce that and run our program. We should get a bit more of a clean effect here. That's a little bit more chaotic. The more you reduce it so it doesn't clutter it up. Oops, wrong button. Didn't want to do that. There we go. We had much more different effect. So you can do some pretty cool things with this, depending on what you want to do. There's lots of options, and it's very, very customizable because of all these different properties we've set up. So play with it, have fun with it, see how many different ways you can apply it within your game, whether that's cool things like a projectile hitting off a wall, or whether that's like something exploding or somebody getting their arm chopped off, whatever. Have fun with it and show me what you can do.